Okay, let's continue talking about enzymes and let's talk about enzyme inhibition, specifically non-competitive inhibition. Last time we spoke about competitive inhibitors. So, a competitive inhibitor, you have your enzyme, you have your active site, and then you have your substrate that is specific to your active site. And then a competitive inhibitor is a chemical that can bind to the active site but does not produce a reaction. So, if this is my competitive inhibitor, it could bind to the active site but fail to produce a chemical reaction. And as long as it's present, because it's not producing a chemical reaction and it's not causing any conformational changes and any of that, it just sits there and occupies the active site, and our competitive or our an enzyme that has the competitive inhibitor bound ends up being occupied. It cannot catalyze reactions because the substrate can't fit. So that was competitive inhibition. Non-competitive inhibition is a little bit different. So in competitive inhibition, they're competing with the substrate for the active site. In non-competitive inhibition, what we have is our inhibitor binds at a separate site from the active site. Right? So, if we've got our enzyme, there's my active site. Here is my separate site, my site other than the active site. Whoop, that erased pretty much everything. Okay, so this is my active site. This is my site other than the active site, my separate site. It is called an allosteric site. So, a non-competitive inhibitor binds at a site separate from the active site, or it binds at the allosteric site. Now, after binding to the allosteric site, it causes the active site to undergo a conformational change. So, triggers a conformational change, and the active site is altered such that it can no longer catalyze the reaction. So that's my allosteric site. Here's my allosteric inhibitor. And when that allosteric inhibitor binds to the allosteric site, the active site gets altered, and now my enzyme is completely inhibited. So, here, inhibition is almost immediate. And they're not competing for the active site. So, hence, non-competitive inhibitor. In competitive inhibition, because, if you have one substrate to one inhibitor, you'd have a 50-50 chance of the substrate versus the inhibitor hitting the active site. And so there's this probability game that goes down. And that's why when you look at, your inhibitor concentration and your enzyme activity, there's kind of this smooth curve causing a decrease in activity as enzyme concentration increases. So that's because they are competing. They're bouncing around each other and competing with each other for access to the active site. So whereas here, if you were to, do a curve of activity, it would be a significantly more drastic curve. Simply because it's not a 50-50 chance that the substrate is going to bounce the inhibitor out of the way or get there before the inhibitor. If the allosteric inhibitor gets into the solution of enzymes and substrates, it'll bind to the allosteric site and shut them down. And that's non-competitive inhibition. So thanks for coming to my TED Talk. Hopefully that one was pretty simple. Boop.